Okay guys, today let's talk about how to draw chairs from cyclohexanes. Now a chair merely represents the most stable form of a 6-carbon ring known as a cyclohexane, taking into consideration this important theme of steric hindrance and atoms wanting to be as far apart from one another as possible. This is a theme we will revisit many times over this course as well as Orgo 2 as far as explaining why things happen or don't happen. You will have 2 chair conformations for any given cyclohexane, and the reality is that they are just flipping between one chair versus another like a million times a second. It just may spend time in one conformation over another based on ring stability. Let's see how best to draw 2 chairs based off of a given cyclohexane. So I've already labeled our carbons here. Didn't bother labeling this tert-butyl group. So when translating these carbon numbers into these rings here, I like to put carbon 1 on this left chair, let's use green, down here. And then you just kind of go around the face of the clock. So this would be 2, 3, 4, 5, 6. Now on this right chair, this becomes carbon 1. Otherwise, you still follow this rule of kind of just going around the face of a clock. 1, 2, 3, 4, 5, and 6. Now, remember, for any given sp3 carbon, you're going to have 2 bonds that are planar and 2 bonds that are 3-dimensional, right? So this terminology of axial and equatorial substituents, this just represents the 3-dimensional bonds coming off of any given carbon or vertice in this ring. So let's take carbon 2, for example. Since we can already see these 2 bonds that are sticks, then by default, the other 2 bonds coming off of carbon 2 must exhibit 3-dimensional space. So this tert-butyl group would be on the wedge bond, and this invisible hydrogen would be on the dash bond. So now, your axial groups are going to be represented by vertical lines, and again, your equatorial groups, both of these collectively are going to be your 3-dimensional bonds. But I like to keep things color-coded because my ADHD is through the roof, and I think it helps just to be able to see things. So axial, let's come over here to this left chair. Carbon 1, we're going to go vertical line down. Carbon 2, vertical line up, and we're just going to kind of flip-flop as we go around the ring. So 3 down, 4 up, 5 down, 6 up. Now on this right chair, we're going to go up on carbon 1 instead of down on carbon 2, and just flip-flop as you work your way around the ring. Now for our equatorial groups, we're kind of just going to do the opposite of what is already there. So looking at this left chair, carbon 1 has an axial line going down, so we're going to have an orange equatorial line going up. 2 already has an axial line going up, so we're going to orange line coming down, or down-ish. 3 up-ish, 4 down-ish, and you can kind of see this pattern. Come over here to the right chair, down, up, down, up, down, up. And you always want to draw those groups outside of the ring as possible. So then there's a little acronym we can kind of remember. It's double D, so dash down. So what that means is, as we're translating these groups onto these chairs, if it's on a dash bond, it's going to be on the down position. So let's start with carbon 1. We have a methyl group on a wedge up. So the up position on carbon 1, we'll just write Me for methyl, and we'll do the same thing over here, the up position. So there's an up and a down position for each carbon, right? So wedge up. We have a tert-butyl group on carbon 2 on a wedge, so wedge up. So we can just write TBU on the up position on carbon 2, and the up position on carbon 2 over here, TBU. And lastly, we have a chlorine dash down on carbon 4, so Cl on the down position here, and Cl on the down position here. Now, often you'll get asked questions on like ring stability, and so they would maybe ask, okay, between these 2 chairs, which one would represent the most stable chair? And generally, especially with something with a big multi-carbon group, such as a tert-butyl group, your most stable ring is going to be when that big multi-carbon group is going to be in the equatorial position. So this one would likely represent our most stable ring here. If you found this video helpful but need more in-depth explanation and see a lot more practice problems worked out, you can find the full-length version over at orgogoat.com. Please like, comment, and subscribe to help our videos find more students like you, and tell a friend. And if you're interested in private tutoring, or if you want a concept explained that you don't see on our YouTube page, shoot me an email at orgogoat@yahoo.com.